So we move on to part 2 of this chapter. We completed a little portion. Now we will go into the significant figures a little bit more and unit conversions as well. So I think we finished up till here, and we talked about the sig fig rules, and we stopped over here. So now we are going to talk about units, standards, and the SI system that we are going to use in our entire course. The units that we are going to represent our quantities in is going to be System International SI system, where the measurement of length is done in meters, the measurement of time in seconds, and the measurement of mass in kilograms. So length, time, and mass represent the three fundamental quantities, and meters, second, and kilogram are their SI conversions, SI measurement units, and these are the standard definitions for length, time, and masses. So, and if SI system is the meter, kilogram, and the second, the CGS system refers to centimeter, gram, and second, and the British system of units is foot, slug, and second. We will be focusing all our attention on SI system. If the units are given in CGS or British system, then you should always convert them to SI system. That's what we are going to practice and work on throughout this course. So these three quantities that we already know, and now we'll go ahead into conversion. How do these conversions work, and why are they important? It gives us a sense of magnitude in different types of set of units. So the range of objects and phenomena studied in physics is immense. From incredibly short lifetime of a nucleus to the age of Earth, from the tiny sizes of subnuclear particles to the vast distances to the edge of the known universe, from the force exerted by a jumping flea to the force between the Earth and the Sun. So if you try to think about the range of forces that we have, or the microscopic particles to the macroscopic distances in the universe, we should have varied units, and converting from one set of quantity to another is an interesting tool, right? Measurements of physical quantities are expressed in terms of units, and these are the units. Meter is a unit, feet is also a unit, and second is a unit of time, hour is also a unit of time, and minute is also a unit of time. But in order to convert from one form to another, we follow a set pattern called unit conversion. All right, so we already talked about these are the conversions given, and normally I always will give you the conversions for the bigger units, like you are not supposed to memorize that 1 feet is 0.3048 meters or 1 mile is 1.609 kilometers. Whenever a problem is given, I generally give these units with the problem as well. So let's practice some examples over here. For conversion from one set of unit to another. For example, if I pick up the speed limit on some interstate highway is about 100 kilometer, I'll put a deliberately decimal over here, kilometer per hour. So this is the speed limit, and I want you to convert it into SI system of units. So if I say SI system of unit, that means you have to convert kilometers per hour into meters per second. And there you have to show me the entire conversion in the form of unit conversion. So let's see how it works. So 100 kilometers per hour is written just like that, and then I will write down its kilometer conversion. So 1 kilometer, you must know 1 kilometer is 1000 meters. I will also, I generally give this in the formula sheet, but this is a simple one. You can even remember this. So the unit you want to convert into and should be on the top, and the unit you want to get rid of should be placed in such a way that it cancels. So here the value, the magnitude of this square bracket is 1. So it means 1. It's not going to affect or alter our answer in any way. So then I go ahead and find out what is the conversion for 1 hour. So we will go ahead in a chain form. 1 hour has 60 minutes, but I don't want unit in minutes. I want answer in seconds. So we'll go one more step down and convert the minutes. 1 minute is 60 seconds. So I'll stop here because that's the objective. And if you look at it, the hour and hour is getting cancelled, the minute and minute is getting cancelled, and the kilometer and kilometer is getting cancelled. The only units that are left now are meters and seconds, and that was the objective. So if you look at this, the magnitude of 1 hour over 60 minutes is 1. The magnitude of 1 minute over 60 seconds is 1. That's why we call it unit conversion. So it does not alter the answer. It's just converting from one form of unit to another form of unit. So to find the answer in its meters per second, we now go ahead and write all these quantities. 1000 meters whole divided by 60 multiplied by 60 seconds. You put all these numbers in the calculator and then you will come up with a number. If you are you write down 27.77 meters per second. But since our problem gave us the number as 3 sig figs, so I'll go ahead and reduce it to 3 sig figs, and I'll round it because this number over here is higher than 5. So we will write down 27.8 meters per second. And this is what we are going to be using in all our problems, okay? And if I ask you to convert it into miles per hour, so we were given kilometers per hour. The second part, if I ask you convert 100 kilometers per hour into miles per hour. I'm sorry, this streaks, this pen has a problem, but we'll manage. We need to know the conversion for kilometer to mile. So one kilometer is basically we have to find the conversion from mile to kilometer. So 1 mile is 1.609 kilometers. So we'll go ahead and perform the unit conversion just as we did in the part A. So we want the mile to stay in the top because we don't want to get rid of it. We want to get rid of kilometer, so it will go in the denominator, 1.609 kilometers. And again, for time, I can simply write down in one step, 1 hour is 3,600 seconds, because this means 3,600 seconds. You can go ahead and solve this way, it's perfectly fine, but I was just trying to save time. Miles and miles stay there, kilometers and kilometers are gone. Now we'll go ahead and multiply all of them and we'll get the answer divided by, so this is 100 miles divided by 1.609 into 3600 seconds. Oh, actually we are going to convert it into hours, my bad. We are just leaving it into miles per hour. Okay, so the question was to convert it into miles per hour. Miles per second is a small value, so it doesn't make sense. Kilometers per hour into meters per second is still a sensible unit, but miles per second is a very small number, so we leave it in miles per hour. That's what we see in the odometer, and we don't have to convert the hour here, so I'll just leave the hour here, and we simply get 62 miles per hour. So 100 kilometers, 62 miles per hour. 100 kilometers per hour is close to 62 miles per hour. This is how we perform our sig fig conversions, sig figs as well as conversions. So if it's a 3 sig fig, I'll put 0 over here, 62.0. That will make it a unit conversion along with the sig fig, taking care of the sig fig. So there will be numerous opportunities for you to do the conversions, and the homework is fully loaded with these types of examples. For example, Mount Everest. If I take again an example of Mount Everest. Mount Everest is at 29,028 feet, and I want you to convert it into kilometers. So convert this number into kilometers. So you need to know that 1 kilometer, what is the conversion of a kilometer into a feet? So 1 kilometer is equivalent to 3,281 feet. So kilometer is a larger unit. So in order to convert, you again perform the unit conversions. That is 29,028 feet. I want the feet to go away, so that's why the kilometer should be on the top, and I want the feet to cancel, so 3281 naturally will be in the denominator. Is in the denominator. So you cancel this and you go ahead and divide this number. Use your calculator. You can pause, and you will see that your number will be 8.847 kilometers. Since our sig figs were 5, 1, 2, 3, 4, 5, but you can also keep the 5 sig figs, but we had this was 5 sig fig and this was 4 sig fig, the conversion, so you can leave it in the 4 sig figs as well. Okay, so this is how you do the unit conversion problems. And what else do we have? I think you'll get enough practice in the lab to work on it. And apart from this, I also want you to remember 3 important units. One is kilo. Kilo is always 1,000, which means 10 raised power 3, and milli, which is the opposite of this, which is 1 by 1,000th, and that means 10 raised power minus 3. And kilo, milli, and deca, deci, we are not using yet micro. I'll let you know. Kilo and hecto, we generally don't use that. So whenever we're using lower, any other numbers, but these two you should definitely know. Apart from that, this chapter will have a lot of other questions too. So again, the highest waterfall in the world is Angel Falls in Venezuela, with a total drop of 979.0 meters. Again, mark the sig figs are 4. Express this drop in feet. So we need to know the meter to feet conversion. 3.281 feet is 1 meter. Okay, so this is the unit conversion for this. I kept one solved problem here. Unit conversion. Unit means 1. Okay, so now you're converting this. Again, watch the meters and meters are going away. The feet stays, whatever we want, on should stay, should not cancel at all. So that's why you have this number. And now when you're problem solving, in all calculations, write down the units explicitly. These are the rules. Treat all units as algebraic quantities. This is not a math class, this is a physics class. If you are not going to write the units with the quantities, they won't make any sense. So for example, if you are defining speed and you're writing 92.9, so if you don't write miles per hour, kilometers per hour, or meters per second, I won't be able to know which unit you have used. So units are very, very important to be written with all the quantities. You will lose points if you're not writing units with the quantities. So use the conversion factors located on the you have in the textbook. Conversion factors are given in the table, so whenever you need, you can find the conversion. And for important conversions in the in exams, I always give you in the formula sheet, so that shouldn't be a worry. And this is also one of the problems that we just did. So practice this one as well. You are converting 65 miles per hour in meters per second, and we just did it actually. So you see that how we converted it from miles per hour to meters per second. We can also convert it into feet per second. So several ways of doing it, and vice versa. You can convert 95 feet per second into meters per second as well. Okay, so all of these quantities represent 1 over here. This means 1, this means 1 also, so unit conversion. Lastly, I want to go into part 3, which is mathematical concept. For this course, you should definitely know the trig part. The important trig part being, you should be aware of what is the adjacent, what is the hypotenuse, what is the opposite, and what is the relationship between them. So if you know SOHCAHTOE, if you know this mnemonic, you should know how to write tangent of theta, cotangent of theta, and sine of theta. So HO is the length side of the opposite angle. So adjacent is always formed between the hypotenuse and the base. So angle is always formed between the adjacent and the opposite. Hypotenuse, and opposite is always opposite to the angle. So remember that. That's why we call it opposite. It's opposite to the angle. So based on this, you will have sine of theta equivalent to opposite over hypotenuse. So this side over this side. And for cosine of theta, you will have adjacent over hypotenuse. And for tangent, you will have opposite over adjacent. So SOHCAHTOE, you will be using this a lot in your course, so that's why I thought that it's a good idea to memorize it a little bit. And if we have to find out an angle, so if we have to find the angle between over here, how do you go ahead and do it? If you have to find height, if theta is given, if the height is not given, how will you find out? Just by the angle given and by the distance from the building. So if one side and the angle is given, you can definitely find this. So that's the beauty of trig. So tangent of 50 degrees, we know the base, that's the adjacent, and we can find the hypotenuse, which is the actual. We can find the height of the building. So there are many advantages to trig, and this is the simplest use of it to find the height of the building. And if the sides are known and you don't know the angle, you can easily find the angle with the help of the formula. Again, sine of theta equivalent to HO over H, and cosine of theta equivalent to HA over H, and tangent of theta equivalent to H naught over HA. So if you have to find inverse tangent, so you can write it in this form, and you can write it in this form. If you have to write inverse cosine, if you have to write inverse tangent, you write it like this. So these things you should already know. Apart from that, we should also know Pythagoras theorem, which is the sides, the opposite and the adjacent square is equivalent to the hypotenuse square. So bear that in mind. If you have to find h, the hypotenuse, you will take the square root of this. So we use this a lot. So these are the mathematical skills that you should come prepared with, because this is this you should already know. But if you have taken math a long time back, it's a good idea to revise your high school physics, high school math, at least pre-algebra, algebra, and if you have done pre-calc, that's wonderful. And also you should be aware of quadratic equations, which I'm going to talk about very soon. And I think we need that in chapter 3, quadratic equations, and chapter 2, when we are going to talk about one-dimensional motion. So if the equation is ax squared of the form ax squared plus bx plus c equivalent to 0, with x being the variable, the roots of this equation are found by the formula minus b plus minus b squared minus 4ac whole divided by 2a. So plus minus are the two roots, so you can find the two roots of this equation. It's a perfect, if you can find perfect factors, then you can easily find it, but normally that's not how we find them. You use the quadratic equations, which is easier method. So please revise these basic concepts before we get into the harder portions of this course, which will start from chapter 3 onwards. All right, so I think we are mostly done with the basic instruction for chapter 1, but during the lab time we are going to get further exposure to sig figs and unit conversions. That will be our first lab, getting introduced to converting units, and also how to use a scientific calculator. So I'm assuming you will have a basic scientific calculator. You don't need a graphing calculator for this class. A simple scientific calculator where we can use tangent, all these trig functions, it should be good. All right.